Well, welcome back, and we're moving on to Chapter 4, which is Areas of Polygons. And this is our first unit of geometry, so you'll be dealing with quite a bit of a difference from last chapter with the algebra. The section that we're working with today is 4.1, Areas of Parallelograms. Get used to spelling that because you'll have to do it here and there, and try to figure out some tricks to do so, because I even sometimes second guess on my spelling of it, but that's how you spell it, with two L's at the beginning and then right here, and then you get the one L after it. Alright, here we go. So the essential question of this section is, how can you derive a formula for the area of a parallelogram? So let's start off with a polygon. A few things that you need to know about a polygon is it's a closed figure, it has 3 or more line segments, and some examples are parallelograms, triangles, and trapezoids. And they intersect only at their endpoints. I'm going to jot those down real quick for you. I'm only going to leave this up for just a second, so if you have to pause it to write it down, go ahead. Let's test some shapes out using the rules we just learned about a polygon. This first shape is a parallelogram. So if we look back at our rules, we already know that some examples are parallelograms, so yes, this would be a polygon. My next shape is a triangle. Same thing. We know that it's a closed figure, it's got 3 or more line segments, so yes, it is considered a polygon. This next shape would not be considered a polygon only because it does not have 3 line segments. It needs to have 3 or more. It only has 1 right here and 2 right here. These are not considered line segments because they're on a curve. Here are just a couple other examples that I've given you that are polygons and that are not polygons. So we all know that this is a rectangle. And when we have these little squares like this in the corner, that's just telling us that that's a 90-degree angle. So my drawing might not be perfect because I'm just using a stylus right now, but these little boxes right here are telling me that this angle right here is 90 degrees on all sides. We also should all know that the area of a rectangle should be our length times width. And we should all already know from last chapter that when 2 variables are together, you multiply them. So because these are together, it would equal length times width. A couple of notes for you. So the formulas for polygons can be derived from the one area formula. The area of a rectangle, which you learned in 4th grade. So we already know that the area of the rectangle is length times width. The process that you use to derive these other formulas is called deductive reasoning. And I'll kind of give you a pattern of what we're going to do throughout this whole chapter. So we start with a rectangle, which we already know is defined by length times width. Then we have a parallelogram, which we need to derive the formula for. If we already know that our rectangle is length times width, what can that say about a shape that looks sort of like that, which is a parallelogram? And then onto a triangle, where we're going to derive a formula, and then onto a trapezoid, which will do the same thing. Now here's the nice part is, this is 4.1, this is 4.2, and this is not until 4.3. So we're going to start with a parallelogram. Alright, so I'm on 4.1's lesson, which is on page 154 in big green. Throughout this, I'm going to do a couple things where I will give you some options to earn a ticket. That was some of the feedback I got from before. Maybe I'll have a joke in there for you. I don't know yet. We'll see how it goes. And if you're really lucky, Lucas might walk in on us because I just heard him outside in the hallway searching for me. So he might be coming in here saying hi in a little bit. So maybe it'll make it a little bit more fun and I won't sound so boring. We'll see. I don't know. We'll see how it goes. So anyway, here's some review from well, we did this a lot in the last chapter, and I was really surprised at how many people got these wrong on the test. But when you see the word sum, it means addition. We should all know that by now. If you don't, you really need to study these. Product is multiplication, difference, subtraction, quotient is division. You're going to see these terms used a lot during the next chapters into 7th grade, 8th grade. It doesn't stop, so you need to know these. So a couple notes for you. First of all, the area of a polygon is the amount of surface it covers. So we're not talking about just around its edges like a perimeter. We're talking about the area. So now we're talking about the entire surface it covers. You can find the area of a parallelogram in much the same way as you can find the area of a rectangle, and I'm going to show you how. So here's our key idea for this lesson. So the area of a parallelogram. In words, it means the area A of a parallelogram is the product of its base B and its height H. And also, here's another key thing. Here's product. We know product means multiplication. If you don't know that, you need to know it because, again, here's one of those terms popping up. So for algebra, we're simply looking at the area equals base times height. And the reason I have a B and an H right here is because, let me get my pen out, give me another color. We talked about base, and I put in parentheses right here that it's a small b. Height, in parentheses right here, it's a small h. So also remember that if that's true, get my pen back, A equals base times height. Don't forget that when two variables are next to each other, in this situation it's a b and an h for base and height, that means they're multiplied. Don't forget that. Example 1 is finding areas of parallelograms. So I'm going to give you an example. I'm going to do the best job I can with my stylus drawing out the parallelograms, so bear with me. But I'm going to give you examples. There's 2 different examples. And the biggest thing that when we're dealing with parallelograms and finding the area is to figure out which line do I put my height on. So I'm going to do the best I can explaining that to you, and we can go over it in class as well. Okay, so if this was my problem, and I told you to find the area of the parallelogram, this is what I was given. This is exactly how you would set it up in your for your homework. You're going to use 3 A's. So the first A, you're going to tell me what is the area, and that's what A stands for, of a parallelogram. So we just learned that the area of a parallelogram is base times height. So that would be my first A. My second A, I would fill in the blanks. This is where you have to say to yourself, okay, what am I talking about? Where's my base? Where's my height? Well, a base of any type of shape, in this situation, your base is your bottom line. And the reason I know that is because they put the height in for you, and they put this little right angle marker there. That right angle marker tells me that's my height. So wherever that line is, that's what my height's going to be. So my base is that bottom line that intersects with my right angle. So don't forget that. Your base is the line that intersects with the height line at a right angle. Or I'm sorry, at a 90-degree angle. Okay? So now I can fill in those blanks. I've got my base, which I just learned was 12 meters. So I'm going to put a 12 here because I just filled in for what my B equals. And then in parentheses, I'm going to put the height because I'm multiplying it by each other. You could also put 12 times, well, my height is going to be 14 because here's my height right here. You could put it like that, or I would accept it like this. But try to get used to doing it this way. My next A is going to be where I solve it. So my area, which is, again, my large A, would be 12 times 14. And again, if you have to do this off to the side, by all means do it. But the answer would be 168. Now, I've been kind of on your case about putting down, if there's a label that you need to put on with your on tests and stuff. I've been a little bit lenient. But guess what? No more leniency. You now have to put it on there, because if you don't, it would be considered wrong. Because we're talking about M, which stands for meters. But it's not just 168 meters. It's 168 meters squared, because we're talking about the area, or the surface, which would be all this space in here. So the full answer is the area of the parallelogram is 168 square meters, which also looks like this. So on a homework or on a quiz or a test, I would expect you to put the 3A's, and then this would be the one that you circle, because that's what I asked you to find, was the area of the parallelogram. In this next example, we have another parallelogram, and this one looks a little bit different than the last one. You have to figure out where your base is, and this is what's really important. One thing you have to remember about a parallelogram is that both sets of lines that are parallel to each other, which means they never intersect, are the same length. Because if they weren't the same length, even if this one was off by a little bit, eventually up the line they would intersect somewhere. So they're always the same distance from each other when it comes to this way. So it's one thing that you need to know, that your height is the line that will intersect. It's kind of an imaginary line just to let you know where the height belongs. So in this situation, your base is not 4 feet. Your base happens to be up here, the 8.5 feet. Now you might get a question that throws you off a little bit, and they might add in another number like this line right here, but that's not a base. That wouldn't be your base. Your base is the line that intersects with your height. So here's our height, because we know this is a right angle. So we know this line is our 4 foot. That would be our height. So we're going to start off just like we had before. We're going to write the formula. So A equals base times height. We're going to say A equals, and we're going to fill in what the base and the height are. Well, because our because our base intersects with our height, and our height is the one with the, right here, with our, making it a 90-degree angle. So our base ends up being the 8.5 feet. So 8.5 feet times 4 feet. So that's the next thing that we write. And then the last A will actually be the answer. Now this 8.5 times 4 takes you back to a different chapter. So if I have a 8.5, I want to make that an improper fraction. And to do so, you say 8 times 2, which is 16, plus 1 is 17. So I can have 17 over 2. So now I have 17 over 2 times 4, and we know a whole number as a fraction is 4 over 1, and we can multiply straight across. And this is where we can simplify our multiplication and cross factor and make that a 1 and make that a 2. So now I have 17 times 2 and 1 times 1. So I should get 34 over 1, which in turn just equals 34. So I just did the math out for you, just as a refresher if you forgot how to do that. So our answer for this parallelogram would be 34, and it would be feet, because that's the measurement they used over on the picture, and it would be squared. And this would be your answer for the area of this parallelogram. Okay, on the next slide I'm going to show you the on your own practice problems. But before that, I'm going to give you the problems that you have to do. So these are mandatory. If you don't have these done the next day in class, it would be a homework pass. So make sure that you're getting these completed so you have some type of discussion question when we come in for that first 10 minutes to discuss with groups. So these are the problems that you have to do. So you're going to do big green on page 156. You're going to do numbers 3 through 8. So 6 problems total. And I'm not working these ones out. These will be only on your, for you to discuss the next day. I'll give you the answers tomorrow in class or the next time that we talk about this in class. But the next page will show you the on your own problems and work them out. So if you're still not really sure about this, look through those. I go very detailed into how to work those out. Also, if you can tell me how many times I said the word, I'm sorry, let me go back. Not how many times I said it, how many times I wrote the word parallelogram. If you can tell me how many times I've written it from this point and, behind, so all the other parts of the video. If you can tell me how many times it is, I know how many times it is, I've already counted, you will get a ticket for going back and backtracking. I don't think there's any in the on your own problems that are coming up next. But so at this point, we're at about 15 minutes. The on your own problems are about 5 minutes to go through them. So if you think you got this and you start doing a couple of them and you got it and you do the practice problems, you feel comfortable with it, I think you're good to go. So I kept this one to 20 minutes. See you in class. Alright, here are the on your own practice problems that were on page 154, right after example 1. Again, I would like you to look at these. If you think you've got this, then I would suggest moving on. But what's nice about these 3 examples is there are 3 different types of parallelograms with different ways the height is written in. So it's really important that you kind of see what's going on. I would really look at the question and make sure you're understanding the answer instead of just skimming all the way through it. But this is your choice whether you do the on your own problems. And here's number 1. Okay, so here's number 1. You've got a parallelogram with a base of 20 meters and a height of 25 meters. And I know that because my height is the line they put in for me, so the number is next to it. With the base is where the height and the base intersect, so that means this is my base. This is 20 meters. So to write this out, I would put A equals base times height, because that's my formula. A equals, now I fill in my formula. I've got a B for base, which is the 20, and my height is 25. And then my last A would be to solve it. So you would just do the math for 20 times 25. You should get 500, and your label would be meters squared. And this would be my final answer for number 1, 500 meters squared. In number 2, they give you a parallelogram that gives you the height on the outside of it. So they've made an imaginary line down here, and they've just connected it to the base. So again, this base intersects with the height. So here's our intersection point. That's how we know that this line is our base. So we've got 7 inches, and here's our height because here's our right angle, and we have 18 inches as our height. So there we go. We would start with A equals base times height. Always write that formula first. You'll be expected to do this in homework. If we're working in our groups, we'll be expected to do this on tests, on quizzes. And then A equals, and then you fill in what we have. So, whoops. Let me get rid of that. So we have, for our base, we said 7 inches. And for our height, we've got 18 inches. So it's 7 times 18, which again, you could do the workout on the side of your paper, but for your answer, you should come up with 126 inches squared, because we're dealing with inches. Don't forget to write the right label. And of course, I would circle my answer. And the last one, number 3. So we have a parallelogram that's in a little bit different of a position. We've got our height way up here. Our height is listed at 20.5 yards, or 20 5/10 yards. And here is our height. Remember, our line can go all the way through. It just stops because that's how we have it in the picture. But if it goes all the way through, then this would be our base. Don't get confused if another problem you see a number here. Like, for instance, maybe they might have 14 yards here. I don't want that to throw you off because, sorry, let me get my pointer. I don't want this 14 yards to throw you off because this is our height and our base intersects it at a 90-degree angle. Okay? It will always intersect at a 90-degree angle. It doesn't matter if it's this one or this one. I've already told you the parallelogram. If this is 30 yards, this over here would also be 30 yards. Erase that, and I'm going to erase that. Okay. So to start this one off, you do the same thing. area equals base times height. Area equals, our base we just agreed was 30. I guess I agreed with myself. And then for the height we would have 20 and a half. And then you would multiply the two together. And you can do out your work and you should come up with 615 yards squared. Again, if you don't have something like this labeled and you don't have your yards and you don't have the squared, it is wrong on a test. Okay, completely wrong. You have to understand that when you're dealing with area, you're dealing with the surface of the entire polygon, so that means you're squaring it. You're using all of that area. It's not just the perimeter.